Hey guys, my name is Mr. Anthony Anumel. I teach at Piedmont Global Academy and I teach 8th grade math. Today, I want us to talk about how to solve systems of linear equations by graphing. So sit tight and let's see what it's about. All right, so before we actually do that, I want us to talk about the types of solutions of systems of linear equations that we have. The first one is when you have infinitely many solutions, right? So it means that on the graph, when you draw your two lines, one of them is going to be directly on top of each other, right on top of each other, right? And so what that would mean is that you're going to have these two lines intersecting at so many places, a lot of places. Right, that's one type. The second one is no solution, where you have the lines kind of parallel to each other. And the last one, which is what we're going to be talking about, is when you have one solution, meaning you have your lines meeting at only one point. So this is a typical example of a system of linear equations. This just means that we have a set of equations. It could be 2, it could be 3, it could be 4, which share the same variables, all right? So what we're going to do is we're going to try and draw these two equations, and that's going to help us solve for the variables, right? So I'm going to start with the very first one. Y is equal to negative 2x plus 5. This is written in the slope-intercept form. And so this means that I can use the y-intercept and the slope to draw my line, right? So by looking at this, my y-intercept would be 5. So this is going to be 5. This is 5. And this is going to help me figure out the slope, right? So for the slope, I'm going to go down twice. So 1, 2. And then I'm going to move once, right? So again, 1, 2, and once helps me to draw my first line. Now, I'm drawing the second one. This has no y-intercept. So I know that I'm starting from the origin, right? But the slope is 3, meaning I'm going to go up 1, 2, 3 times, and then just move to the right one time, 1, 2, 3 times, and then move to the right one time. And that is also my line. So I'm going to draw this also. I'm going to try and make this a dotted line so that you can see the difference. Pardon me if I don't draw the best line, but it's going to look something like this. So again, this helps me to figure out the solution of my system. So all I'm going to be doing is I'm going to be reading what the value of that point is. And from what it looks like, this solution is at the point 1, 3. 1, 3. 1, 3. So again, we want to try and see if we can verify this. And I'm going to show you that in the next clip. So hang on. So we're going to verify again to see if this is correct. Right? And the way we do it is this. For our solution, we're going to put each of these into our two equations and see if what we get on the left side becomes equal to what we get on the right side. All right, so let's pick this first one as an example, our very first one. So we have y is equal to negative 2x plus 5. Right? We know that this is our x and that is our y, right? So if my y is 3, I'm just substituting this, and this is what I'm going to get. And if my x is 1, this is what I get. All right, so now I'm going to simplify this to see. I know that this is 3. And this becomes negative 2 times 1, which is negative 2, plus 5. And that gives me 3 as well, right? So 3 is equal to 3, and that is correct, right? So again, if it works for the second equation, then it means that our answer is correct. So let's see if that's the case. Again, my equation is y is equal to 3x. My y is 3 and my x is 1. So if y is 3 and my x is 1, it brings me back to the same answer, right? And that is my answer. I hope you learned something new. This is how you solve systems of linear equations by graphing. Hope to see you again, and take care.